Welcome. This is my Unit 3 math interview. The interview question for this unit was, with the three following equations of the planes, for what values of k will this intersect at a point, at a line, and not intersect at all, in which case there's no solution. And so to start off, I decided by thinking about no solutions, where I could figure out a scalar quantity to multiply one row by to figure out if it is parallel or not. I use this row just because the other ones have variables inside, and so there's no actual scalar quantity that I can use to multiply a 4y with to get 5y, and then the same quantity to get 5y to 22y. And so my second idea is to use a matrices, in which case 0, 0, 0 would give you a value of x. Because in that case you're saying that 4 equals 5, or 0 equals 2, or something like that, where it does not make sense. The second thing is when there's a line, in which case 0z would equal 0, because then you can still use the Gauss matrices method and figure out a value of, and try and make the bottom row 0, and this 0, because then you're saying 0z equals 0, where z can be any number and that'll still hold true. And so if you follow me right here, I plugged into matrices, I plugged in the coefficients to solve the matrices, and so our goal here is to make this a 0 and this a 0. And then using this and this, we can make this times z equal whatever value is here, because that's ideally what you're saying. And so if you continue looking on here, you know, if we want to get a 0 here, we can do row 3 minus 3 row 1. So it's so that would basically mean you're doing 3 subtracted by 3. If you follow here, that gives you a value of 0. I continued on doing that to get the rest of the values. And then what I noticed is if I want to work with if I want to work with the 0 and any of the row, then ideally if I add or subtract, it'll get rid of this. This will get rid of the 0. And so I want to make this a 0 as well, just to ensure that it does not change. So I did k times row 1 minus row 2, because then I'm saying k minus k equals 0. And so I continued on doing that for this row to get these values. And now my next goal was to make this negative 34 become a 0. The only way I found it would be easy to do that is if I did row 3 times 4k plus 5, so I could multiply it by this part of row 1, and then added 34 row 1. And so ideally what I'd be doing is the same value in a negative form plus the same value to get the value of 0. And so I continued on doing that because it gives you 0 here. So now we have the two zeros, plus we got a quadratic equation here, and we got a quadratic equation here. And so now what I want to do is figure out what values of k will does this side equal 0. Because in that case I'd be saying 0z, and where the whole thing represents the 0. And so if I do 0 equals this, we can use the quadratic formula, or just factor simply, because in this case they're all divisible by 8, and so it works faster. And then on this side we have 4k squared minus 31k minus 45, and we want to make that side 0 as well. Because if we make that 0, then we're saying 0z equals 0. And so again, you can use the quadratic formula, the negative b plus minus square root of b squared minus 4ac over 2a, and figure out the values of k, in which case that works. So if you follow me right here, we have 8k squared minus 8k minus 48, so we can common factor the 8 out first. Continue on, you get k squared minus k minus 6, and so in that case you're saying it adds to negative 1, multiplies to negative 6. And so for that we get a value of k as 2, and another value for is negative 3, so k plus 2, k minus 3. So in that case the value of k is negative 2, and the value of k is 3. Now for the 4k squared minus 31k minus 45, there's no simple value that you can use to factor out, and so I decided just to use the quadratic formula and plug in the values of a, b, and c to the equation right here. And the way to do it, that was the easiest way to do it, in which case I got a value of k as 3, and the value of k is negative 20.75, or 3 over 4. And so in both cases we had a k equals 3. And so what that basically meant is 0z equals 0, because we were saying that this side equals this side, in which case that meant that was our equation of a line. Now the second part is we get a point negative 2 as k, and we get negative 20.75. And so if one side has a negative 2 and the other side of the k has to be a negative 20 over 3 or 4 to make them both equal 0, then we know if we keep one side as negative 2 and the other side as negative 2, you'll get a different value on the right side, and so you'll have 0z equals some value. And so in that case, there is no solution. And so now if you think about it like this, if we have a value where there's no solution, if you have a value for it to be a line, at any other point, ideally, it can intersect at a point. And so for where k is a number in the real number system, as long as it's not negative 2 or 3, it will intersect at a point. And so ideally it can be a point when k equals any other value. And so for example, k could equal 4 and it'll intersect at a point. And so again, for if it's 3, it'll intersect at a line. If it's negative 2, it'll intersect at it won't intersect at all. And if it's 4, for example, it'll intersect at any point. Thank you.